Okay, picking up from where we left off on last video. So we just converted the lists, the temperature and the pressure lists from the website into the 64-bit from the string. So now it's in 64-bit. And now what we want to do is set variables for those T and P values in that data array, and we'll use these to model our first graph. So first we want to make the variables. So we'll just go ahead and make T is temperature. So temperature is equal to, and then data. So then the data array from the initial value 1 or 0, but Python starts at 0, and then we'll go to the end, so colon, and then same thing for pressure. The log of pressure will do log underscore p, and log underscore p, and then that will be set equal to np for numpy, and then log 10, and then we'll do 1,000 times the data. As this way, the data will be represented on the pressure data will be from 4 to 7 instead of from just 1 to 4, so create a wider range. And then we'll just do from 1 as the second iteration, and then to colon, so to the end. And then we'll go ahead and shift enter that. And now our next step will be to create the figure, this first figure with these variables. So first we're going to have to import a couple more things. We're going to have to go import from plotly dot subplots, and then we want to import make underscore subplots, and this will allow us to create the subplots from plotly. And then we'll just press enter. And then we also want to import plotly.io and then as PIO. And we'll be good with that. Okay, so now that that's done, we can go back down here and start making our figure. So the first thing we need to do is just fig, and then we'll do make underscore subplots. And then once we make subplots, we need to specify the rows of the plot and the columns. So we'll do rows equal 1 and cols equal 1. Okay. And then once we've done that, we need to specify which plot we actually want to make. So in this case, we probably should do scatter plot. So we'll go ahead and do fig add and then underscore scatter. And then once that's done, we need to set our variables for our figure, and we need to get this chart layout set to what exactly we want it to be. So we'll go ahead and set our x equal to t, and then our next argument we will set our y equal to the log underscore p. Okay, and then we want to specify the mode next, as you can see. So this mode, we'll just create the scatter mode, and we'll just do markers because that shows up the best. And the next thing we want to specify is the marker size. So marker underscore size, and we'll just set this equal to 7. Okay. And then once that's done, we want the marker color. So we'll do marker underscore color. And then we'll just set the marker color equal to black. Okay. And now that we have the marker color, we can do the marker outline color. So marker underscore line underscore color. And we can just set that equal to blue. All right. And then we can also set the width of the marker. So marker underscore line underscore width, and we'll just set this equal to 1. And then we'll just make the name of our markers in the legend, and we'll just call that data. Okay. All right. And that should be it for the layout. I mean, it's kind of optional. You can mess with this marker line width, and you can kind of mess with these colors to see what fits best, but these are the ones I'm just going to use for now. And then we'll add a couple more chart elements, and so we'll update the layout. So fig.update underscore layout, And we will just make, say, we'll just make the chart 850 for its width. Oops, width equals 850, and then our height can just be set to 450. Okay, and that sets the height and the width for our chart. And then we can add one more chart element, the fig update underscore layout. And this time we'll just do the titles and the title labels. So we can do the x-axis underscore title, and we can just have this equal temperature in Kelvin. So just do temp and Kelvin. And then we will have our y-axis underscore title, and we will just have this equal, we will have this equal the log, the log underscore p. So we'll just set this equal to log base 10, and then just do that. So we have the log underscore, and then we do the braces to make it the base. Oops, log underscore, and then we need to use these braces to make the base 10. And then we'll just do that P divided by, and then just PA. Pressure divided by actual pressure. And then we can do that, and then we need another $sign in order to get that brace to disappear when we show it. So we have that. And I think we're good. We can go ahead and press Shift Enter. And then now we can actually show our figure to see what it looks like. So we'll do Fig Show, and then go like that, and then we'll just do Shift Enter. And then, as you can see, we have our y-axis right here and our x-axis right here, and then this is our model for the data of temperature and pressure. Now the goal is we want to define a new model in order to set parameters and make it, or we can fit the parameters to the Antoine equation of the data. So we're going to have to define a new function in order to do that, and we can just call that a new model. So define model, and then we'll need to set our parameters for that model, which in this case will be A, B, C, and T. Okay. And then we need a colon because it is a function and has a syntax. So, and then we can return the Antoine equation in terms of the log of pressure. And then in that case, it would just be A minus B, and then over C plus T. Oh, T capitalized. Over C plus T. Okay, and we're good on that. So we can Shift Enter that. And then the next thing we need to do is set the initial values for A, B, and C in order to fit the parameters to the data. So we'll just go A initial, and we'll set that as 15. And then we'll do B initial, and we'll set that as 2000. And then we'll just do C initial, initial, and we'll just set that as 0.00. Okay. And now we want to have this variable x0, and this is the initial guess in NumPy for an array, or in SciPy for an array. So we'll just do x0, and then that will be equal to the initial parameter. So we'll do A initial, and then B initial, and comma C initial. Okay. And once we have that, we can go ahead and start our sum squared error. And this is so we can cancel out the positive negative deviations of the data and make it more accurate. So we'll have to start a new function for that. So we'll go ahead and Shift Enter this. Actually, we don't necessarily have to Shift Enter this. We'll just go ahead and keep typing below. So we'll start a new function right here, and this will be our sum. This will be the function we're trying to take the sum squared error of. So we'll just call it sum SQ error. Yeah, that's fine. Sum SQ error. And then we want to set the parameters. So in this case, we have the x and the t, and also the log of the underscore of p. So right there. And then it's a function, so we got to put a colon, and then after that, we need to set a variable for the model of pressure. So we'll just do model p, and then we'll set that equal to the model of the initial parameters of A, B, and C, of the initial values. So in this case, we'll just do the x in the array. So the first one, in this case being A, we'll just do 0. And then the second one being B, x1, and then the third one being x2, which is C. So this helps us set the parameters into the array of which value they come. So 0 being A, the 1 being the B value, and the 2 being the C value. And then also we need to add the T as well. Okay, and then once that's finished, we can make our error equal to, and then we have to use the JNP for the JNP numpy. As you can see up here, we have to use the JNP for jacks in order to minimize the loss of precision. And we will do that by just doing JNP, and then we want to take the sum squared error. So we want to take the sum of these two models and then square them up. So we'll just do sum, and then we will do our model P, model P, and then minus our log underscore P, and then we will take those two and square it. And once we've done that, we have completed our sum squared error, and then we can just return the error. All right. Okay, and the next thing we want to do is minimize the sum squared error. So to do this, we are going to need to make a new import, and that will be the SciPy optimize as minimize import. Okay, so we just do from SciPy dot optimize, and then we just do import minimize. So we import the minimize command, and then we'll just shift enter that, shift enter all the way down. Okay, and once we've done this, we need to create a return value for the result of the optimization, and then this will be named as RES. Put RES, and then this will be where we minimize our sum squared error. So just do minimize, and then sum squared error, and then we have our x of 0. So the x of 0 is, oops, messed up. X of 0 is equal to x of 0. I'm messing this up. X of 0 is equal to x of 0. And then we want to input our arguments. So args equals, and then the arguments we have our temperature. So temperature being T, and then our pressure being log underscore P. Okay. And once we have that, we can then set a tolerance for the minimization, and we want to make this very small to get the most accurate. So we can just do tol equals 1e to the negative 10th. We'll just go ahead and set our tolerance as that, and then we just go ahead and shift enter this. Shift enter. Oh, I have made a mistake. I believe this is our error right here. So we have our sum squared error, we have our minimize, and then our res. Okay, let's try it one more time. Oh, I did not. I believe the problem was that my res was inside of the function, so that is why we had that error right there. So we'll go ahead and shift enter. And okay, so now that we got that figured out, we actually need, now here's where we'll create the last figure that fits these parameters to the data of temperature and our pressure values. So to do that, we need to make one more temperature model. So we'll go ahead and do temp model, and then that will equal. We'll have to do the JNP dot linspace. This will create a equally spaced lines in between the data. So then we'll just do t at the first iteration, and then we will do t at the -1 iteration, and then we will do that 100 times. Okay, and then we have that. Okay, so now that we have that temp model in, we need to finally fit these parameters to the data and create a new scatter that can show us that. So what we need to do is add another figure. So we do fig.add underscore scatter. And then we'll need to, since our x was t defined up earlier, we just do x equals our temp model. X equals our temp model. And then we have our y equal to the res parameter of our minimized sum squared error and the temp model. So we'll have to do this correctly. We need to do res.x, star res.x, and then temp model, because that is our model we're setting up. And then after this, we need to create the mode. So we'll just do mode. We'll just do mode equals, and then we'll do lines because we want a line to go through our data. And then we'll just set our, let's say, line width. We need to set our line width. We'll just make that 1 to be simple. So line width equals 1, comma, and then we need to name what that's going to show up as what that line is actually going to show up as on our plot. So we'll just call that Antoine equation because that's what we're representing. And we'll just call that Antoine equation. And then last step is we need to just show the figure and do that. And then we just do shift enter. And it seems that I have made a mistake in my data. Let me go back through and make sure I have everything correct. Okay, so our x is equal to our temp model, and our y was equal to, oh, we forgot to do something. We forgot to add the y model in because that was the error we created. So we have to do the y model is equal to that. So this should fix our graph. So we'll just go ahead and do shift enter. Oops. And seem to have made a even bigger mistake here. We have fig to add scatter, and then okay, I accidentally, I'm not, so I apologize. The model should be after the equals because we're setting up this model with the res x and the temp models, those parameters for the model. So we actually need to do model, and then we put those. So the equal sign should have been in front of that model. So I think this should fix it. So shift enter. And it seems that it is still not registering correctly. We have the arg is equal to that. Mode lines, name. And then we have that. And we did our sum square error correctly, I believe. Model P. And then x0, x1, x2. And set our parameters. To return the error. And then we used, let me go ahead and try to shift enter each of these, reshift enter these to make sure this is working. Okay, so we have our first model, which is right there, and then we define our second model right there, and then we set up our initial values, A, B, and C, and then we define our sum squared error, calculate it, right here, and then square it, and then we minimize the sum squared error with RES, sum squared error, and then we have 0, 0. Yep, everything looks right to me. And then arg0 equal t log PV. Yep. And then our tolerance was equal to 1 times to the negative 10th. So I think this should work. So we have that. And then we now have, go back to this step, and we'll go ahead and shift enter that. And oh, there we go. I think the problem was that I needed to reset all of the, after changing, I needed to shift enter this, which I might have forgot to do in the beginning. But now our model is finished. We have the parameters set from the data to the Antoine equation. And as you can see, we have a relationship between the log of pressure over the actual pressure and the temperature in Kelvin. And this is what our final plot should look like.